Welcome to JD's Prep. So we have a few questions here about stars. So we're given a flow chart here, and we're asked to use this flow chart to identify the characteristic of a main sequence star that determines whether the star becomes a giant or a supergiant. So what we are looking at is we have a more massive main sequence star here and a less massive main sequence star here, and that tells us supergiant or giant here. So the characteristic of that main sequence star that determines whether it's a supergiant or giant is just its size or its mass. Next, we're asked to state the name of one star labeled on the characteristic of stars graph, which I've pulled up here from the Earth Science reference tables, that may become either a black hole or a neutron star. So again, from this flowchart, a black hole or a neutron star, we are looking for the more massive main sequence stars or the supergiants. Okay. So we have the main sequence stars here, the more massive ones, maybe up here, the supergiants here. Any of these stars here would be appropriate answers for this question. Next question asks us, what is the process that occurs when lighter elements in a star combine to form heavier elements? So that produces a ton of energy. That process of lighter elements coming together to form heavier elements, that is nuclear fission. And lastly, we're asked to circle the relative surface temperature and relative luminosity of the main sequence star Sirius, which is right here, comparing with the surface temperature and luminosity of the sun, which is right here. So this is essentially just reading this graph, okay? So the relative surface temperature of Sirius, we have Sirius compared to the sun, the surface temperature here, we have a lower temperature and it's higher over here. So Sirius has a higher surface temperature than the sun, and the luminosity is over here on this axis. Luminosity lower, higher. So again, Sirius has a greater luminosity than the sun. All right, thank you for using JD's Prep.